I guess it does confirm these top three are still functional. It does seem, however, that we have to have them plugged in prior to booting up the unit. Otherwise, it will not detect. So we're going to go ahead and move forward with the replacement of that bottom display port here. And all right, let's start the disassembly. All right, so I have the graphics card here on the bench, and we're going to start by taking it apart. So I'm going to flip it over, and we have a lot of screws on here. So I'm going to get started with, let's see, some of the smaller ones around here. And these screws are screws that are screwed into the plastic shroud. And I'm going to leave the heatsink screws for last. Okay, I think that's all of them. All right, I'm going to tackle the larger ones now. Those two over to the side. And then the heatsink screws. There we go. All right, and I guess I'll use the little organizers here. Okay, so I believe that's all the screws. Yeah, it just came right off. All right, so the last thing we have here is just this connector. I'm just gonna carefully wiggle it out. And now I'm not grabbing the wires because they are very thin, and I mean, this is an old card, so they're fairly heat stressed. So what you want to make sure to do is actually grab the corners of the actual connector itself, so to not put any pressure on the actual wire. So here we go, it's all apart, and we do have this heatsink. I think this should just lift off. Yep, it does. Okay. All right, and it's pretty dusty, so we're definitely going to want to do a little bit of a cleanup. This is what we have inside, which, I mean, makes sense. You know, these cards have a lot of air flowing through them. So, and there we go. So that's the disassembly. Next, oh, actually, no, there's more. We have this metal piece here. All right, so we have more screws. And on this one, I'm going to do the small screws first, and then I'm going to tackle the larger ones. All right, we have a little bit of rust and corrosion, it looks like. We'll see if we can take care of that as well. This one is giving me a little trouble. So for these types of screws, you really want to make sure that you have the correct size screwdriver. I have a few sizes, I have more as well, but if you're not using the correct size, it's really easy to strip these, and once you start stripping these screws, you're in real trouble. It's going to become really difficult very quickly to actually get them out. So just make sure you're using the right size. It really makes a world of difference. All right, and Juan, do you mind passing me some pliers? Just the needle nose over there, or yep, that'll work. Thank you. No, that's good. All right, and lastly, we just have these guys here. All right. Once you have a few rotations, you can do the rest by hand. Wow, this one's really tight. Wow. So they actually do sell a specific screwdriver that fits around this and would make it easier. And I believe we do have it as a part of a iFixit kit that we bought. And let's see, actually, is this it? Hey, there we go. Thanks, Juan. Yeah, that makes it a lot easier. Having specialized tools makes a world of difference. Yep, look at that. So if you don't have this, obviously you can just use needle nose pliers. It's just a lot easier and faster if you have the right equipment. Okay, so now that is off, and that is the last piece. So after this, the next step to replacing this guy is going to be removing the DVI port first, because it's going to be in the way. I won't be able to access those pins back here. Okay, so I have our graphics cards currently held by our helping hands, and it's sitting just above our mini portable bottom heat station. So what I'm doing right now is I have it at around 350 Fahrenheit. Technically, the melting point for leaded solder is about 360 degrees Fahrenheit. Now, it's a pretty high temperature, but the board's actually sitting fairly high off of this machine, and that combined with when I have my vacuum on, it's going to suck a lot of the heat away, and because it's a few inches away from this platform, it's really not getting even close to that temperature. So that's what why I have it so high, and that's partially because the DVI port protrudes so far off the board that I just need it to be a lot higher off of this rework bottom heat. So, all right, I have been preheating this for about 5 minutes or so. You know, I can still touch the board for a couple seconds without burning myself, but it is pretty hot, and that's what we want. I'm going to start with getting the nice and loud vacuum fume extractor on. And the first thing I'm going to do is put a little extra flux all over the board, all over the joints that we're going to be working on, because these boards are very thick. They take a lot of heat, so I'm going to need all the help I can get. So right now I'm putting flux on all of the joints, the grounding supports, and also the pins. Now, I said leaded solder earlier. This board I do not believe, oh Jesus, this board I don't believe has leaded solder, but I'm going to be using leaded solder, and leaded solder has a lower melting point than the solder that's on here by default. So this should help me, and I missed one of them. Oh no, actually never mind. I was going to put flux here and here, but that's actually for the display ports, which we'll do eventually, but not right now. So I'm going to be putting this leaded solder on here, and I'm going to be mixing it with the original solder that is on these boards, and that's going to help me get better flow, because again, these boards are very thick, they have very large ground pads, they take a lot of heat. Oh. There we go. All right, now I'm going to add more fresh solder, leaded solder to the pins. And at this point, I'm actually going to just try and put a lot of extra solder on here if I can. All right. Perfect. And now, oh, actually I have a lot of solder on my iron. Let me get rid of some of that. Now I'm going to get an assist from the hot air. Turn that on. So I'm going to go full air pressure 100%, and I'm going to be heading up the 400 Celsius. So the preheater is at 360 Fahrenheit, and we're going 400 Celsius. Of course, they're all in different units of measurement, which doesn't make it easy, but that's just how it is. I believe 195 Celsius is the melting point for leaded solder. And we're just going to keep going around. I'm going to be hitting all the pins, all these supports, going back and forth constantly. All right. I'm just going to be wiggling this thing out. Oh man, it's really in there. There we go. Whew. Wow, this thing was really in there. Yeah, we were putting a lot of heat on there. I generally don't like to put this much heat, but these boards just require that. So while everything's still hot, I'm just going to go ahead and suck up all that extra solder to make nice, fresh new holes for the reinserting the port or a new port that we're going to be installing, which most likely will be the case since there's actually a lot of corrosion on that one we just took out. I added a little extra solder in this hole because I was having a hard time getting it all out. I got most of it out, but a lot of it has still some of the original solder, which is non-leaded, so that has a higher melting temperature. So I put a lot more fresh solder that is leaded with a lower melting point, and usually that helps with getting some of that solder out of there if you're having a hard time. Here we are on the display port. So we have a lot of dust, and this pin down here is a little concerning because it looks like maybe it's rusted or corroded. I'm not sure exactly, but we're gonna go ahead and use some isopropyl alcohol to just clean it all up. So I'm just gonna spray that and just use this toothbrush, just get a little cleaning. And we do still have it on the heat plate, so the alcohol is going to evaporate pretty quickly here. Alright. Okay, yeah. Looks like we might have a little damage there. Hopefully it's nothing we can't handle, but we'll see. Alright, so our next step is, just like before, we're going to add a little bit of flux. Go, and then a little bit of solder. Actually, I'm going to rotate this. Be a little easier for me with this angle. Yep. There we go. Yeah, I'm having a really hard time with that first pin getting fresh solder on there. So there's not really any metal for it to stick to, it looks like. Alright. So my big concern here is if it doesn't have good flow, is that gonna rip out the pad when I try to remove the port. which maybe it might. So we'll have to be careful. Let's see. I'm just trying to think the best way to do this. Yeah, you know what? I'm going to attack it with heat from the top. So we did previously, we added some solder and flux to the pads over here. But we're going to do the same actually from the front, from the top. Let's see here. More flux. Flux is your best friend. There we go. Alright, this is kind of hard making sure that everything's in view of the camera. Alright. And I'm going to angle it just a little bit so you guys can see better. Okay, so I'm just getting my iron in there and getting all those joints melted. And we're getting some pretty good flow actually, which is promising. This one's actually going to be... Oh. Let's see. This one's probably going to be a lot easier to remove than that DVI port. Alright. Okay, and again, we're going to use our hot air now. And we're going to keep an eye on the solder. Once it gets real nice and shiny, we'll know it's ready to lift off. Okay, and it looks like it is. Oh, look at that. Beautiful. A little smoky. That's because of all the flux. Okay, and let's take a look at that trace. Oh, it's actually in pretty good condition. Okay, good, good. That's great. That means that we don't have to rebuild it or replace it with a new one, so that's going to make it a lot easier. So one thing I'm doing as well is I'm putting my iron on the desolder wick and then I'm folding that over the iron. The reason I do that is to increase the surface area that is making contact with the iron, and that's going to help more heat transfer, or it's going to help to increase the heat transfer between the iron and the desolder wick, so it's going to make it easier for the solder to get soaked up into the wick. Soldering is all about heat transfer. Woo, that's getting hot. Alright. Cool. Looks a little messy, but we're going to clean that right up. I'm going to let the board cool down a little bit before I spray alcohol on it. So we're going to do a quick little pause here and come back to it in a minute. Alright. Okay, So we just waited a minute or so, and I'm going to use some Q-tips now. Let's do a little cleaning. Now that it's a little colder. I mean, it's still very hot, as you can tell, but it's a lot cooler than it was a minute ago. Okay. Whoa. All right. That's looking a lot better. Nice. All right, so let's get our new port in here. Okay, so it looks like we made a little bit of a mistake with the audio, and the microphone actually turned off. So I'm going to be doing a voiceover and just describing what we ended up doing. So we just lined up the new display port, and I'm actually going to be starting off by soldering the ground pins, the support pins from the back first. Okay, and when I was doing the soldering work, I was actually having a little bit of a hard time with the iron. It wasn't really melting the solder properly, and that's because the tip was not tinned properly, meaning that I had no solder on there. So it was actually really hard to get the heat from the iron tip transferred into the actual solder to get it melted. So that can happen just generally from either having an old tip, or if you had the tip, let's say, on for an extended period of time, it can just kind of burn itself out. So just that comes down to just general maintenance and making sure that you clean your tip before and after you finish and start soldering. For example, if you don't have solder melted onto the tip and left on the tip to solidify when the tip cools down, the metal on the iron can corrode or oxidize, and when that happens over time, the tip will stop transferring heat properly. So really the fix is replacing your tip, or I think there's some devices you can buy to help refurbish the tips. We don't have those, but what I ended up doing is just adding a lot of solder in the areas where the iron was in good condition, and then help the solder flow over to the areas that were not so good, and essentially just extended the tip to the areas that were affected to help get good flow. Alright, so I got the grounding pins here covered in solder, so the port is fixed and it's solid on the board. I'm just going to hit those pins with a little flux. And the tip I'm using here is fairly large, and it's good for larger ground planes like those supports, those grounds pins that we just did a second ago, but it's not really ideal for smaller fine pitch soldering. So in a second you'll see me actually switch to a much smaller tip. Okay, so we just switched to that much smaller tip, and it's actually going to be a lot easier. Okay, so right now there's a couple blobs of solder, and what I'm doing is I'm actually just trying to push all that solder over to the edge, because I had plenty of solder on the left side, but I didn't actually have enough solder on the right side. So I'm pushing that solder over to the area where it's needed. And then the rest of that excess we'll want to get rid of. So with that smaller tip, it's easier to solder the pins, but again, the soldering, the secret to soldering is that heat transfer, and since that tip is much smaller, it has a lot less surface that makes contact with the desolder wick, so it's a little harder to remove solder with it. There we go. Okay, so we got rid of that last excess of solder, and I think we're all set. We can go ahead and get that tested. Yeah, it looks pretty clean. Oh, actually, we're gonna use a dental tool actually to make sure that all of the pins are making proper contact. So we're just checking every single pin here, making sure that they're all soldered on properly, and they are. So we're all set. We're gonna probably do a little bit of cleaning first, and then we're gonna go ahead and do a real quick test before we put the card back together. Make sure that it's in good condition, that the port's working properly, because we're not going to want to find out if it's working or not after we put that DVI back in. That thing was very difficult to remove. So we're going to do a quick test, and then we're going to finish soldering the DVI back on and put it back together. Okay, so we did check it, and everything was functional. So now we're going to be wanting to put in the DVI. So this is the original one. Obviously there's no point in putting that in. There's a ton of corrosion in there. It's disgusting. It's most likely non-functional. We didn't actually test it because of the amount of corrosion in there. So we're actually going to be putting a new piece in there next. Alright, so I have just spent the last 5-10 minutes desoldering a new one that's nice and clean. It's still not in perfect condition, but that's the best I got, and I know it works. So that's what we're going to be working with here to reattach. And on the last video, we were still working, or the last video, the previous recording, before we flipped the board over, I was still working on getting these cleaned up. And that's what we're going to finish up right now before we install the new port. So we're going to go ahead with a little more flux. All right. And actually, what we were doing previously is giving the board a little extra heat with the hot air. Don't want to go too long because we have the capacitors over to the left, and if we do too much heat for too long, we can pop those, and obviously we want to avoid that. So I'm only doing a little bit. Okay, and we're actually having a little bit of a hard time over here. So what I'm doing here is I'm using some low melt solder, which is different than our leaded solder. And the melting point for this one, I have no idea. But it is supposed to be better than the leaded. If I find out more details on that one, I'll put it in the description. So it looks like actually the solder I just put on here is just sitting on top of the old solder. It is not actually going through and bonding with the old solder, which is the whole point. Alright, so here's what I'm going to do is now that we have this new solder on here. What's that? No, you can keep it the same. I'm gonna inject a little more heat here. Again, I'm gonna be careful. I have those capacitors. So I'm actually angling the hot air away from those to try and minimize the amount of heat going towards them. Alright, and that should help. Fresh piece of desolder wick. Let's give that a shot. Well, I'm getting a couple of them, but not all of them. We'll just keep working our way through here. Try and get as many as we can cleaned up, and we'll come back for the rest that are giving me trouble in a bit. Okay, so I did find out why I was struggling and having so many problems, and it looks like my bottom heat was turned off, and because of that I was not able to get enough heat into the board. I still have a couple here. Just having a hard time. Can't quite get them. Alright. We're almost there. Oof, what a nightmare this one is. Alright, there we go. That is all of them. Just double check. Look at that. Yep. I just got a little flux in there. But I assure you that is one that is taken care of. Just looks like there's still some solder. It's just flux. So we'll just clean that out. Oh, there we go. Alright, so now that everything is cleaned out, all the ports are good, we can put our new DVI port in. Let's see, does it just fit? Ah, okay. So something we did not do, so we'll do that next, is our DVI port has old solder, and because of that, it's a little, the pins are a little too thick with that old solder, so we'll need to clean all that off first. That should be a lot easier though. There we go. Alright. Now let's try that again. Ah, alright, so I am realizing actually we have two more holes here that were not properly cleaned out, so we'll go ahead and do that right now. I'm going to get that solder nice and hot. Oh, so not able to get all of it. go. Okay. Alright. Alright, and there's a tiny little bit left here on the side, so we're going to try and clean that up. Okay. Alright, perfect. Alright. Now we should be able to put the new piece in, hopefully with some relative ease, without burning ourselves. Let's give me a little resistance here. There we go. Alright. And I'm going to start with the larger grounding supports. There we go. And so for these larger pads, I'm actually hanging out on the joint for a little longer, just because it's taking a little longer for the heat to transfer into the board and make good contact. Alright. Let's see. Looks like we ran out of solder. Of course. Alright, and these are much smaller pads, they're not large ground pads, so I don't need to hang out as long and provide as much heat. And it looks like I'm actually double soldering. There we go. And I'm actually just going to go over it one more time, a little more flux, just to make sure everything's 100%. Yep. Oh, look at that. Beautiful flow. You can just see that solder melt, get shiny. Alright. And that's it. Slow cleanup now. Final cleanup. I'm going to start with the Q-tip, trying to absorb and get rid of some of the flux off of the board. And then we'll clean up the rest with the toothbrush. Alright, so that's looking pretty good. A little more alcohol. I'm not going to clean it until it's perfect because we're actually going to put it in the ultrasonic cleaner in a bit. This board does have a little corrosion on it, and it's also pretty dirty. It's got a lot of dust. Okay, so we just got the card back together. It's hooked back into the system. Right now I have the display port hooked in that we just replaced. So I'll go ahead and boot it up. And we did actually, yeah, we tested this previously before the whole card was put back together to make sure, just because you do want to find out before you spend the time to put it all back together, the pads, the thermal paste. So looks like it is working. We have the display port operational again. So we'll turn it off and we'll go ahead and try the DVI that we also replaced. Make sure that's still functional. Oh, actually, I have to go to the different input for that. And most likely I'll have to nope, okay, so we're booting right in. Okay, cool. So our display port and DVI are fully functional now that it's been replaced. We'll do a little bit of stress testing because we did take the heatsink off and put new thermal paste and all. So we'll do that next, and we're all set though. Every port is fully functional now. So thanks for watching. Remember to like and subscribe.